We're going to get a little bit more practice with our trig functions. We're going to look at another example, and I think why don't we even just tie in the Pythagorean theorem. So trig functions, and we'll look at the Pythagorean theorem just to confirm that, you know what, both of these things are talking about right triangles, just from different approaches, so they're definitely connected. So let's look at our right triangle. We have a right triangle, and here's our right angle, and we're told that this angle up here, theta, is equal to 0.36 radians. So again, that means it's equal to 0.36 of a radius of a circle. And we want to know, well, if this hypotenuse is equal to 2 times the square root of 73, what does, let's look at this leg down here. Eventually you want to find both legs, but let's start with this one. Well, that's going to be equal to the sine of 0.36 radians, because that equals our opposite, right? From our angle, the opposite side is down there, and that is equal to something, we don't know, over 2 times the square root of 73. And the sine of 0.36 radians, right, we're not memorizing this, we're looking this up, is 3 times the square root of 73 over 73, which equals x over 2 times the square root of 73. If we multiply both sides by 2 times the square root of 73, 2 times the square root of 73, right, these cancel out, 2 times the square root of 73 over here. Well, now x is going to be equal to, how do we do this? Well, 2 times 3 is 6, and the square root of 73 times itself is just 73. And then we're going to divide by 73. So these cancel out, and our mystery side is just 6. So now we know that, well, let's find the other side. And there's a lot of ways we can do this. We could use our tangent of theta, which is the tangent of 0.36 radians. And tangent's equal to the opposite, which we now know, right? This is no longer a mystery. X is equal to 6. So the tangent of 0.36 is equal to 6 over an unknown, which is easy to do, but not as easy as the cosine of 0.36, which is equal to the adjacent side of the angle, the mystery, over the hypotenuse, which is over 2 times the square root of 73. And we can also use the Pythagorean theorem, because really what's happening here is we know our leg and our hypotenuse. We just want to know what is the other leg equal to. So we've got a couple of things to work with here, and I think we should work with both one of these other trig functions and the Pythagorean theorem, just to remind ourselves that, yeah, all this trigonometry ties into each other. All of our right angle theorems have some connection. So our Pythagorean theorem and our trig functions are definitely connected. So let's just rewrite that so we have some room. And we'll look at the Pythagorean theorem first. So we know that this side is 6, and this side is 2 times the square root of 73. And we know that with the Pythagorean theorem, a squared plus b squared is c squared. Well, a squared is just 6 squared. B squared is unknown, we don't know. It's going to be hard to tell my 6's from my b's here. And c squareds are long hypotenuse, and that's 2 times the square root of 73 squared. This equals 36, that's 6 squared, plus b squared equals 2 squared, which is 4. Square root of 73 squared is 73. 4 times 73, well, 4 times 70 is 280, plus 4 times 3 is 12, so 292. And so if I say this right, 4 times 70 is 280, yes, plus 4 times 3, which is 12. Okay, so now we have 36 plus b squared are unknown. So b squared is equal to 292 minus 36, and b squared is equal to, well, 292 minus 36 is just 292 minus 30, which is 262, minus 6 more, which is 256, and that's a perfect square. The square root of b squared is equal to the square root of 256, and b, square root of b squared is b, equals 16. So actually this mystery side, this unknown, according to the Pythagorean theorem, is 16, right? That's 16. But what if we use the trig function? Let's just see what'll happen if we do that. If we use the trig function, will we also get 16? So we, again, going back, we knew that this side is equal to 6. Here's our right angle, and we knew theta over here was equal to 0.36 radians. And we also knew our hypotenuse is 2 square root of 73. So now we have this new unknown, and I think I'm going to go with the cosine of theta, the cosine of 0.36 radians, because it equals the adjacent, the unknown. Let me use y this time. We'll call this y. It's our unknown, adjacent side, over the hypotenuse. I could have used the tangent as well, but I think, and I'll leave it to you to think about why, but the tangent might have taken me an extra step or so, especially with the method I've been using. So the cosine of 0.36, if you look it up in a trig function table or on the calculator, is 8 square root of 73s, right? 8 of them over 73 equals now y over 2 times the square root of 73. I'm going to multiply both sides by 2 times the square root of 73. And really what's going to happen here, these cancel out, and y is going to be equal to 2 times 8 is 16. And it looks like, well, maybe we're going to get a different number than the Pythagorean theorem. But again, the square root of 73 times itself is just 73. Over 73 is 1. So y equals 16. And I think it's neat to see how, oh, look at that, we use the Pythagorean theorem or our trig function of cosine, and if we did it with tangent as well, we get 16 no matter what way we looked at it.